Acids, write the name. Acids are usually the least favorite of all of my students because they are the most difficult to name. The common question is, when do you use hydro and when do you not use hydro? Well, we know acids always start with hydrogen, so whether or not you use hydro depends on the second element or polyatomic ion. If the second portion that makes up the compound is just an element which is found on the front of the periodic table, this is when you use hydro. When it's a polyatomic ion that's found on the back of the periodic table, do not use hydro. And instead of using hydro for the polyatomics, you'll use a different rule. If the polyatomic ends in ate, you'll change it to ick. And if it ends in ite, you'll change it to us. Okay, so for number 91, we have HBr. Well, Br is found on the front of the periodic table, so I'm going to use hydro. So this will be hydrobromic acid. And you always change the ending of an acid to ic if it's in this form. So hydrobromic acid. For 92, the name will be carbonic acid. Because if you look up CO3 on the periodic table, well, it's going to be on the back of the periodic table, it'll be called carbonate, and you'll change the ending from ate to ic. Okay? And the ways we said to remember this was to remember a little saying, which is, don't bite, it's infectious, and what I ate was icky. So you can remember to change ate to ick and ite to us. For everything else other than molecular compounds, you have to crisscross oxidation numbers in order to write the name. In order to write the formula. So for example, hydrofluoric acid. Well, we always know that the cation is hydrogen, and it's H plus 1. Well, it's fluoric, so I know that fluorine is going to be the anion, and its charge is -1. And I'm just getting this off of the periodic table. If you look at the top, there's numbers that are circled with charges. So group 1's +1, group 2 is +2. It skips through the transition metals. Group 3 is +3. I'm sorry, group 13 is +3. Group 15 is -3. Group 16 is -2, and group 17 is -1. So because fluorine is in group 17, the charge on it's -1. I'm going to crisscross these oxidation numbers, and it forms HF. Okay. For nitric acid, well, there's no hydro in the name of this acid, so I know it has to be a polyatomic ion that's mixed with hydrogen. So I always have hydrogen as the cation portion. The anion portion is going to have to be some sort of polyatomic ion. We have two options. It's either going to be nitrite or nitrate. Well, remember, what I ate was icky. And don't bite, it's infectious. So I know because the ending is ic that it had to be nitrate. And nitrate is NO2, NO3 -1. So when you crisscross the oxidation numbers, you just get HNO3 as your final answer.